Hello, everyone. This is Introduction to Periodic Table. Before starting this topic, I normally want my students to do this game. So to get this game, all you have to do is type Professor Jody Selko and type periodic simulation. It will come up. Then I show you how the game looks. It's more of organization of periodic table without you really knowing anything. Okay. Okay, what happens here? This is the simulation. Okay. You can copy down this link if you want. Then what you do is you start by reading the instruction and you click here. And your goal is to organize this. Okay. So to know if you're right, you put like this one. I got this from here and put it here. When you see the symbol, it tells you that it's in the correct spot or correct location. If not, you keep on trying. You have to try to figure it out yourself. Okay, at the end of this video, I will show you how the final product will look like. Then after that one, you complete that, it will tell you if you're right. Then you go to this one and you put this in this section. Okay. After that, you go to this one. Remember, when you are doing this, you have no idea what, you are just trying to figure it out. Okay. It's my sense like it is fun. So it helps us a lot. And later on. Okay, the first thing we do is to look at the periodic table overall, like we looked at this when we did the structure of the atom. So we have to understand about every information here. So we have to look at the key again. This is the key that gives information of each square in this periodic table. So this is atomic number, this is the symbol, this is the name of the element, and this is the average atomic mass. And again, elements are arranged in the order of atomic number, okay? I just want to review this before we get into other things, okay? Periodic table is divided into three main parts. You have the zigzag line here. Because zigzag line, some people call it diagonal line, some people call it staircase. Okay, this staircase separates the metals from non-metals. Okay, everything on the left side of the staircase is metal. You see, everything on the left side is metal. Everything on the right side of the staircase is non-metal. Then on the staircase are the semi-metals or metalloids. Okay. Though this element is located here, it is a non-metal, and that's hydrogen. Okay. So periodic table is divided into three main parts: metals on the left side of the staircase, non-metals on the right side of the staircase, except hydrogen, which is supposed to belong here, and then metalloids or semi-metals. Okay. Metals on the left side of the staircase, non-metals on the right side of the staircase, metalloids on the staircase, except aluminum. Aluminum is not metalloid, though it's on the staircase. It's not a metalloid. Aluminum is metal, okay? Then this hydrogen is a non-metal, though it's on the left side of the staircase. So metalloids or semi-metals are elements that are not clearly metals or non-metals. They're in between. They have some characteristics of metals, some characteristics of non-metals. So let's look again This periodic table, again, then the solids, the key is telling us which ones are solids. You see, most of the elements are solids. Liquids, there are only two liquids, only two elements that are liquids in the periodic table. There's mercury and bromine. Those are the only two elements that are liquids. Then the ones in red are the gases. Okay, they are the gases. And these elements, these ones, that's like fence is gray, they are not found in nature. So they are man-made elements. They are not found in nature. They are man-made elements, okay? So it's important to know this. Periodic table is filled up with so much information, and you have to know them for you to use it effectively. So in this periodic table, there are some of the elements. We have rows are horizontal, and groups. So we have, there are 18 columns. If you can look at this number on top, there are 18 columns. You see that? It has 18 groups. 18 groups. Okay? 1, 2, 3, 4, 5, 6, 7, up to 18. 18 groups. There are 18 groups in the periodic table. These are sometimes called families because each group have similar characteristics or similar properties. So because of that, they are called families also. Okay? And there are horizontal rows. These horizontal rows are called the periods. Okay, if you look, there are 7 periods. The horizontal rows are called the periods. Look here. This belong here. You see this? This is also period 6. Then this period 7 belong here. So when that the periodic table is more extended, we see that later in a video you'll be watching. So this period tells us about energy levels. So if an element is in period 1, it means it has 1 energy level, something like that. So there are 18 groups and 7 periods. So periodic table is organized in rows and columns. A row in the periodic table is called periods. It tells the energy level. There are 7 periods. A column in the periodic table is called groups. There are 18 groups. Elements in the same column share similar properties, so they are also called family. There are special groups in the periodic table, special names, like group 1 is also called alkaline metals. You have to know this. That's group 1. So instead of saying elements in group 1, they may tell you alkaline metal. Then you know that means it's in group 1. Then group 2, they are called alkaline earth metals. Then everything here are called transition metals. Then we have halogen, that's group 17. Okay, group 18, they are called noble gases. Okay, they are called noble gases. Okay, then these ones, everything here is called lanthanide, actinide. Okay, lanthanide, actinide. Then this and this are called main group elements. So these are the special groups. We'll be pointing that out sometimes, so you know. There's so much information about periodic table you know. As I said in the beginning, remember that simulation, this is how this one will look. And this is, you see, if you get it right, you say congratulations. Okay? So it's really something you try to do. You're supposed to have completed before watching. I would like you to watch this video. This video is interactive, so get your periodic table ready and go along.
In the first video, we saw that all the things in the world are made of incredibly tiny particles called atoms, and also that there are 92 different kinds of them. Most things have more than one kind of atom in them, but this nugget of pure gold contains only gold atoms. So we call it an element. An element is a substance made of only one kind of atom. Zooming back out, we see that the gold atoms become a lump of gold again. If we zoomed out from silver atoms, we'd see a lump of silver instead.
Looking for a bladder leak pad that keeps you dry?
When I'm at work, I need to feel secure. What I'm looking for.
Because there are 92 kinds of atoms, there must be 92 elements too, one for each kind.
You probably have already heard of some of them, like carbon, iron, and aluminium, or aluminum if you're American. But maybe not astatine or ytterbium. With so many elements, there's a lot of names to remember. Fortunately, there's a list showing all the elements. It starts with the element with the lightest atoms, hydrogen, and goes to the element with the heaviest atoms, uranium. This list is called the periodic table. How about grabbing your own copy now and check it as you watch the video? The lightest element, hydrogen, is at the top left-hand side of the table.
Each element can be written with a shorthand using one or two letters called its symbol, which is capital H for hydrogen, not surprisingly. Each element also has its own number showing its place in this list, called its atomic number. Hydrogen is the lightest element, so its atomic number is 1. Zooming into helium at the top right, we can see that its symbol is He, big H, little e, to make it a bit different to hydrogen's. And its atomic number is 2, being the second lightest element. The third lightest element is lithium, so it has an atomic number of 3. Where's lithium? It starts the next row. This row goes up to atomic number 10 before another row is started. How many rows are there? 1, 2, 3, 4, 5, 6, 7. The periodic table has 7 horizontal rows. What about these rows down below, called the lanthanides and actinides? Well, they really belong to rows 6 and 7 and should slot into these spaces. The lanthanides are elements 57 to 71 and the actinides are elements 89 to 103. To slot them in, we have to make the periodic table wider. This full table is more accurate and some versions are printed this way. This layout also makes it easier to see how many elements are in each row. 2 in the first row, 8 in the second, 8 in the third, 18 in the fourth, 18 also in the fifth, 32 in the 6th, 32 in the 7th. Altogether, there are 118 elements. HC.
How come? Aren't there meant to be only 92 elements, with uranium being the last one? Yes, but clever scientists have made artificial elements in the lab, like neptunium and plutonium, the elements next door, that were made in 1940. These new elements make the overall list of elements a bit longer. Let's collapse the periodic table back to its usual shape, which is more convenient for fitting onto the screen.
You can see that the periodic table is also arranged in vertical columns, which scientists call groups. How many groups are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 18. 18 vertical groups. The key point about groups is that they contain elements that are similar to each other, like members of a family. For example, all of group 1 elements except hydrogen are soft, malleable metals that explode when you put them into water. Some groups even have family names. Group 1 elements are called the alkali metals. Group 2 elements are the alkaline earth metals. Group 17 are the halogens, and Group 18 are the noble gases. Now you're ready to read the periodic table. What is the name of the element with atomic number 30? You just have to scan around and find 30. Zinc. What is the atomic number of calcium? Now you've got to find calcium on the table. 20. Which row is sulfur in? The 3rd row. Choose any element in the 5th row. There are a lot of possible answers for this. Could be strontium, tin, iodine. You choose. Which group is chlorine in? Group 17. Choose an element in group 15. Could be nitrogen or arsenic or any of the others. Your choice. But what if you were asked which element is in row 5 and group 2? There can only be one answer: strontium. Each element has its own unique combination of row and group. Can you see the grey diagonal band that splits the periodic table into 2 parts?
This divides the elements into metals on the left and non-metals on the right. What is a metal? Here's a few: titanium, iron, chromium, aluminium, silver, and gold, with the atomic numbers above the symbols. Have you noticed that these metals are shiny and solid? They all are, well, except for liquid mercury.
Metals also conduct electricity and heat. Here, the different metals are connected to an electrical circuit. If the bulb lights up, it means that the thing is an electrical conductor. They all are. Metals are also malleable, which means that if you belt them with a hammer, they'll flatten into a thinner shape. Here you can see that aluminium has 3 metallic properties. It's already been flattened into a thin sheet, it's shiny, and it conducts electricity.
I'm a bee, and I bumbled my way into your car. Buzz.
We looked at aluminium, titanium, chromium, iron, silver and gold, all to the left of the diagonal, and saw that they all have metallic properties. What about nonmetals to the right-hand side of the diagonal? They're the opposite. Most nonmetal elements are liquids or gases, but there are a few solids, and these can be more easily tested. Here, sulfur and selenium are showing that they don't conduct electricity. Can you see that the bulb doesn't light up? And if you hit this carbon with a hammer, it smashes into bits. This is called being brittle. It's the opposite of being malleable.
Let's use the periodic table to predict whether an element would be a metal or a non-metal. How about osmium, atomic number 76? Osmium is to the left of the diagonal grey band, so it should be a metal. How about iodine? That's to the right of the diagonal line, so it's a non-metal. Let's try something trickier. Do you reckon yttrium, atomic number 39, would be shiny? It's to the left of the diagonal line, so it's a metal. So it's probably shiny. Would phosphorus, atomic number 15, conduct electricity? It's to the right of the diagonal, so it's a non-metal. Probably not.
What about the elements inside the diagonal band? Let's take a look at silicon. It looks shiny like a metal, but if you whack it with a hammer, it breaks into bits. So it's brittle like a non-metal. And the dull glow of the bulb tells us that it conducts electricity more than a non-metal, but not as much as a metal. And this gives it the name of semiconductor. These elements are also called semi-metals because they have properties that are in between metals and non-metals.
Are they more metal or non-metal elements? Metals. Nearly 3/4 of the elements on the periodic table are metals. But that doesn't mean they're more abundant, because in the Earth's crust, there are more oxygen and silicon atoms than the rest combined. And the universe as a whole is mostly hydrogen.
In fact, hydrogen is special in lots of ways. It's to the left of the diagonal, but it's not a metal. Well, it can't be. It's a gas. It looks like it's in group 1 as a member of the alkali metals, but it can't be because it's not a metal. The truth is, hydrogen doesn't belong to any group, and it's considered to be a group all by itself. Some periodic tables even put it on its own to show this. Just remember, hydrogen is special. The periodic table squeezes a lot of information into a small space. The English writer C.P. Snow said that the periodic table took all the jumbled facts about the elements and fitted them into a pattern, and it was like turning a jungle into a garden.
My view is that the periodic table is the alphabet of the universe, whereas our ordinary alphabet is a list of letters that can make all the words in our language. The periodic table is a list of elements that can make all the substances in the universe.
Now you finish watching the video, I'd like you to answer these questions using periodic table. Pause the video and answer these questions. Here are the answers. Okay. Hopefully you got it right. I added this here. Additional questions. Okay. Now, this is optional. Okay, this is the practice question again. I think I messed up. I showed you the wrong slide. And then you pause the video and answer these questions. Okay. There's so much information in the periodic table. So my advice is to have this, you see this website for periodic table. If there's any element you want to know about that element, all you have to do is click on that particular square, like oxygen. Okay, it gives you every information. You see, you can read more. Everything you want to know about oxygen. Okay, it's always good to know that there's this kind of information, which because it's hard to finish about each element. Many of these are so useful in real life. Okay. If you like, watch this song about periodic table.
Of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
Magnesium.
aluminium, silicon,
Phosphorus.
then sulfur, chlorine, and argon,
Potassium.
and calcium so you'll grow strong,
Scandium.
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
Niobium.
molybdenum, technetium,
Ruthenium.
rhodium, palladium,
Silverware.
then cadmium and indium,
Tin cans.
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, the bismuth for your tummy,
Polonium.
astatine would not be yummy,
Radon.
francium will last a little time,
Radium.
then actinize at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olivinium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, meitnerium, dubsadium, mercenium, copernicium, natrium, flerovium, pentium, livermorium, septium, noctium, and then